Assalamu alaikum students. We will cover question number 5 to 8 in this video. So let's begin. Question number 5 is if z1 and z2 belongs to complex numbers, then prove that modulus z1 plus z2 whole square minus mod of z1 minus z2 whole square is equal to 4 real part of z1 into real part of z2. There are some identities which we are going to use in it. Okay. The first one is this, that whenever there is a mod of z square, it's always equal to z into z bar. Z1 plus z2 whole bar, then we can change it into z1 conjugate plus z2 conjugate. Okay. Initially we will use these two identities. Later on I will tell you that what further we are going to use. So I am taking the left hand side. Let's begin. z1 plus z2 whole square minus z1 minus z2 whole square is equal to, according to this property, z1 plus z2 plus z2 conjugate minus z1 minus z1 minus z2 conjugate. Now I have to put this property on this. z1 conjugate plus z2 conjugate minus z1 minus z2, z1 conjugate minus z2 conjugate. Now we are going to multiply them. z1 conjugate, z1 z2 conjugate, z2 z1 conjugate, z2 conjugate. Here minus sign, z1 conjugate minus z1 z2 conjugate minus z2 z1 conjugate minus plus z2 z2 conjugate. Okay. Now this minus sign will apply to every number. Minus is plus, minus is again plus minus is minus. Okay, that is how we will write. Now we will check out for the numbers that can be cancelled out. z1 z bar can be cancelled out, z2 z2 bar is cancelled. So we are left with 2 into z1 z2 bar, this one and this one, plus 2 into z2 z1 bar. Okay, so now we will take it common and we will express it as 2 into real part of z1 z2 bar. Z equals to a plus iota b, z bar equals to a minus iota b. Now add them up. A plus iota b plus a minus iota b. These two will be cancelled out. What will be the result? 2a. Write 2 and real part of z. What is a? A is the real part of z now. So we will write it like this. So putting this result here, 2 into real part of z1 z2 bar. Now you will think that this is considered as z, but how this is z bar? How this is z conjugate? If we will consider z1 z2 whole bar as a z, then z1 z2 conjugate whole conjugate, take it as like this, z1 conjugate and z2 will be like this, because double conjugate of any complex number is a number itself. It can also be written as z2 z1 conjugate. So this is how This is Z1 Z2 bar as an one complex number, and this is its conjugate represented as this. So we will write it as 2 into real part of Z1 Z2 whole bar. Okay, which can be written as 4 into real part of Z1 Z2 bar. Okay, now the answer which we want is 4 into real part of Z1 into real part of Z2. How will we get that? Z1 Z2 bar, multiply them. Z1 is already a plus iota b, Z2 is c plus iota d. A plus iota b multiply by c minus iota d. Multiply them. AC minus iota AD plus iota BC plus minus minus iota square BD. Iota square is always equal to minus 1. Minus minus is plus, so this is plus BD. AC plus BD. Take common iota from these two. BC minus AD iota. So as you see, this AC, A is the real part of Z1 and C is the real part of Z2. Okay, so it is written here. Okay, real part of Z1 and real part of Z2. This is how we will get the result of this proof. चलिए जी, question number 6 is find the value of lambda if Z1 by Z2 plus lambda whole mod equals to square root of lambda plus 2, where Z1 equals to 3 plus iota and Z2 equals to 1 plus iota. Let's begin it with the Z1 by Z2. Okay, first we will solve this one. When Z1 is 3 plus iota and Z2 is 1 plus iota. Divide and multiply with 1 minus iota. 3 when multiplied with this will give you 3 minus 3 iota, and iota when multiplied with this minus iota square whole divided by 1 square minus iota square. We are going to implement the formula of a square minus b square, which is equal to a plus b and a minus b. Okay, iota square is always equals to minus 1, so minus minus is plus. 3 plus 1 is 4. Minus 3 iota plus iota will give you minus 2 iota. Iota square is minus 1, so minus minus is plus, and 1. 1 plus 1 is 2. Further, when 4 by 2 minus 2 by 2, cut it out, you will get 2 minus iota. Okay, so Z1 by Z2, the answer of Z1 by Z2 is 2 minus iota. Now we are going to put it in this equation. Instead of Z1 by Z2, we will put 2 minus iota plus lambda whole mod is equal to square root of lambda plus 2. Okay, when we open a mod, the mod is basically depending on square root of real part. Square root, under the square root you have to put real part square plus imaginary part square. So real part is 2 plus lambda and imaginary part is minus 1. Okay, so we will put the square like this. Okay, it is as it is. Now we will cancel out the square root from the both hand side. To open the square, 2 square plus lambda square plus 2ab. Instead of 2ab we will write 4 lambda. Minus 1 square is plus 1. Now lambda square plus 4 lambda. 4 plus 1 is 5. Lambda plus 2. Shift these two to this side. 4 lambda minus lambda is 3 lambda. 5 minus 2 is 3. Okay, so this will be like that. Now we are going to put quadratic formula on it. You know, quadratic formula is for lambda it will be, instead of b we will write 3 B square matlab 3 square, which is 9. A is 1 and C is 3. Dividing by 2, A. A is 1. Square root of 9 minus 4 into 3 is 12. This is minus 3. We can also write minus 3 as 3 multiplied by minus 1, and instead of 1 we are minus 1, we can also write that was like square root, so we will put square root here, and then we will write square root of 3 with iota. Okay, because square root of minus 1 is always equal to iota, so we will write it like this. Like, it doesn't affect the answer if you will write iota here or here. Okay, so this is our required answer. This is the value of lambda. In question number 7, we are going to verify this property that square root of 2 mod of z is greater than equal to real part of z mod plus mod of imaginary part. For this, let's say we are going to start with this. Open up, shift it up, okay. So now we are going to add x square plus y square on both sides. Now x square plus y square is always equal to mod of z square, and this is also equals to mod of z square. X square plus y square plus 2xy is equals to x plus y whole square. This is equal to 2 mod of z square. Now we will apply square root on both sides. We will get x. You can also write it as mod of x, mod of y. Okay, so this is x plus y, and you know that x is the real part of z and y is the imaginary part of z. So this has proved the identity. Question number 8 is write in terms of x and y, z equals to x plus iota y. So wherever we see z, we will put the value of z. Okay, the first part is 2z minus iota whole mod equals to 4. Instead of z, we will put x plus iota y minus iota, which equals to 4. Now multiply 2x plus 2y iota minus iota equals 4. Now put the formula, that is 2x square plus 2y minus 1 square. Minus 1 because iota has a coefficient 1, so we put minus 1. 4. Now square root, put square on both sides to cancel square root. Here we are left with 2x square. 2x square is 4x square. Put the formula of a minus b whole square here. 4y square plus 1 minus 2 into 2y. 4 into 4 is 16. Okay. with 4x square plus 4y square plus 1 minus 2 into 2y equals to 16. Minus 2 into 2 is 4y. 16 will come to this side. It will turn into minus 16. Okay, now 4x square plus 4y square minus 4y plus 1 and minus 16 is minus 15 as an answer. So this is our answer. Okay, so part number 2 is z minus 1 whole mod equals to z bar plus iota whole mod. Okay, instead of z put x plus iota y minus 1 and z bar, z conjugate. Instead of z conjugate put x minus iota y plus iota. Okay, here we go with x minus 1 is the real part and y iota or iota y is the imaginary part. In this case we have x as an real part and 1 minus y as an imaginary part. Okay, so putting the formula x minus 1 whole square plus y square, and here x square plus 1 minus y whole square. Okay, when we put the square on the both sides, square roots will be cancelled. Now put the formula of a minus b whole square here and a minus b whole square here too. A square plus b square minus 2ab. Okay, that is how we will write it. Now cut the same things, same numbers or variables. 1 is on the both sides and y square is also on the both sides. Minus 2x equals to minus 2y. That will be cancelled. So we are left with x equals to y. It can also be written as x minus y equals to 0. See in part number 3 z minus 4 iota mod plus z plus 4 iota mod equals to 10. So first of all we will put x plus iota y minus 4 iota. X plus iota y plus 4 iota equals 10. Now put the formula of mod x square plus y minus 4 square square plus y plus 4 square equals to 10. This took the form of ellipse. So when we compare it with the formula of ellipse, what is it? Foci will be from origin to plus minus center. Okay, see, and the basic formula for it is x square by a square plus y square by b square equals to 1. So here when we compare it with the above one, then 2a equals to 10, a will be 5 and center will be 4 because y is 4 plus minus 4, and b square will be a square minus c square. That is, what is a square? 5 square minus c square is 4 square. So this is 25 minus 16, which is equal to 9. So when we put these things in this, so the equation will be, put it here, x square divided by a square. Instead of a square we will write 25. Instead of b square we will write 9. And now reaching the answer which we have in the book, we will multiply the whole equation with 225. So here we will be left with 9. Here we will be left with 25. This. And if you want 25x square plus 9y square, then you can rearrange this equation. 25x square plus 9y square equals to 225. Number fourth part is 1 by 2 of real part of iota z bar equals to 4. For this, we need to check out that what is z bar. If x plus iota y is z, then z bar will be, z conjugate will be x minus iota y. Okay, now multiply iota with this all, then we will get iota x minus iota square y. That will be iota x plus y. Okay, and this thing is basically, now if we want the real part of this thing, then that will be y, and it will be, y will be considered as real part of iota z bar, because this is z bar and this is multiplied with iota. And when we solved it, that then y is the real part. So here, instead of this all, we will write y. Now we will multiply 2 with this 4, and we will get 8 as an answer. Imaginary part of z minus 1 divided by 2 iota, which is equal to minus 5. So first we will sort out this z minus 1. Z minus 1 divided by 2 iota. Z minus 1 x plus iota y minus 1 divided by 2 iota. Okay, for this we will multiply and divide it by, or you can check out that imaginary part. What will be the real part of this? X minus 1 plus y iota whole divided by 2 iota. Then we will get x minus 1 divided by 2 iota plus y by 2. So imaginary part of z minus 1 divided by 2 iota will be x minus 1 divided by 2, because it has an iota with it. X minus 1 divided by 2 equals to minus 5. Multiply this 2 here. Now add this 1 here. Our answer is x equals to minus 9. Part number 6 is minus 2 is less than equal to imaginary part of z plus iota, which is less than equal to 3. This is also interesting. Z plus iota, first we will solve. That is x plus iota y plus iota, and in this real part is x and imaginary part is y plus 1. Okay, so imaginary part of this z plus iota is y plus 1. Now put it in this inequality. Okay, now this one we will subtract from both sides. Minus 2 minus 1 is minus 3. 3 minus 1 is 2. So we'll get this inequality as a result. In this way, we have sorted out all of the parts of question number 8, and 5 to 8 are completed. In the next video, inshallah, we will meet up with the question number 9 and 10. If you have any queries, please let me know in the comment section. तब तक के लिए जहाँ रहें खुश रहें शाद आबाद रहें, हमें दुआ में याद रखें. अल्लाह हाफिज़.